Alright folks, Eric here of the Additive Guru channel. I'm going to walk you through how I created this little beauty of a tool. It is actually a monitor bracket. And the way what it works is, or what it does is essentially, draw you a little picture here real fast. What it does for us is it allows us to take a monitor, typical computer monitor, and attach it to one of the desk mounts that have the little VESA Monitor brackets on it and have like a pivoting point. So you can attach it to your desk, hook it onto your desk, and then in this case hook it to this. The only problem we run into though is that it's not high enough. We need it actually to be, we need the bracket that you see here to be a little bit lower. That's a horrible X, but you get the idea. We need it to be here, and we need an extender to get it up to that point. There's our overall goal with this. And now granted, this kind of thing is something you can buy these type of arms all the time, but they just have a limited height that they can achieve, and past that height you're sort of out of luck. So in this case we're going to make an adapter that allows us to screw to the 4 points on the monitor or the arm, this one, this one, this one, and this one, and then connect it to the 4 points in the monitor itself. There, 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 and there. The only difference is, you got to understand, is that this thing is going to be up fairly high. It's going to be slightly tilted forward. So the arm itself might be okay in holding all this, but the extender is going to be under a lot of stress because of the weight of the monitor pulling down and wanting to sort of tilt it this way. And so that's why you see some of these features. Now, just for reference, a VESA standard monitor bolt pattern is, I think it's like 75 by 75 or 100 by 100. So different monitors use different patterns. In fact, actually most of these brackets actually have 2 sets of holes so that you can use the 75 by 75 or the 100 by 100. We are going to go with the 100 by 100. So both of these are actually a nice, perfect 100 millimeters apart, and it makes for a very easy pattern. And what we're going to do is we're going to mount it in such a way that if you're looking at this from the side, so we're going to mount our part onto it, and it's going to go in a little bit and connect to the monitor. Now the reason it goes in is because the monitor that we're using actually has some depth to it, so it's got to go into that place. And so there's your monitor, here's your arm going back, and this is our design. And of course, as you might imagine, the stress is going to be right in this area right here. So there's our overall target. This is what we're going for. Now let me show you how we create it. Now in this particular case, I'm not going to go through the process of sorry about that. I'm not going to go through the process of every single step on how to make it. I'm just going to walk you through actually what I did to make it and show you some of the logic. You can easily follow along with this process just by kind of like capturing some of the dimensional information and going from there. It is a fairly handy feature. The couple of things that I want you to know is obviously it was generative, and I want you to notice especially how thin these components are. Even though these 4 holes are attached to the monitor brackets or the arm itself, this is hardly any material right here, and yet you have plenty of material up front. So that's really interesting when we take a look at it. Alright, so let's get into it. This is how we made it. I'm going to go ahead and edit my very first sketch, and I want you to notice a couple things. First off, I started off with one pattern, one circle. I made it a diameter of 6 because it's an M4 screw. That's the size of the standard receiver holes in the monitor. And so I made it a 6 diameter, and then I made it a 12 diameter bigger than this. So this circle represents the hole that the bolt goes through and the actual larger cylinder. And from there, it's just a matter of doing like a quick pattern. You can create rectangular pattern, and I set it to 100 by 100. So this one's 100 up, and then these two are 100 across. Now I could have obviously copied them or just drawn the same thing 4 times. Either case, no problem with either one of those, would have worked. But the pattern's pretty fast. The next sketch that I did though is this one. I came up 20 because, as you'll remember in my little sketch that I was doing, if this is the arm itself, I am bolting to these points, and then I am bolting in, well, it's a little bit deeper, but I'm bolting deeper into the monitor itself, and there is a height difference. There's about 20 millimeters up that I needed it to be higher than it was. So, well, actually quite a bit higher, because it's really 100 plus 20, so 120 all the way up. But anyway, the 20 gets me to the bottom one, which is this one, and then I did a pattern again. You can see that I've duplicated the diameter across all 4 of them. Again, you can make this without a bit of problem. So 8 holes, all in line with each other, 100 by 100, and that's pretty much all of my sketch. And the reason I did it as a single sketch is so that I could do things like this. My first extrusion, as you can see, is just to extrude out the bottom holes, which will be on the monitor arm. Then my next extrusion were the other holes, or the other cylinders, that are going to be part of the overall, deeper into the object. So nothing super, special about this, because these have to go in deeper. I am going to extend them out, so you'll notice what I'll do next is I actually add another sketch. And if you look at this sketch, all I'm doing is adding a little extra depth there. And so I extrude out that one, and then you see that I've added a deeper cylinder, and then do a rectangular pattern so that I have this. This allows me to have a deeper thickness in the generative design, so just a little bit thicker. And then one more sketch, and then one more sketch, which actually creates my block, which is my object or my obstruction, so that the generative doesn't go into where the monitor needs to be. After that, adding in a little bit of a chamfer, then a little bit more extrusion, and then creating a feature that will block out part of the monitor arm itself. Because if you look at these, you will see that these monitor arms typically have a brace on the back. And so I have to put this in the way so it doesn't interfere with that connection there. So that's what that's there for. And then one more extrusion that I did, you'll see that I actually extended these cylinders out a little bit more so they kind of match up. And my last one is just add a quick fillet just to kind of put those edges. And that's all of my design. 1 block, 2 blocks for obstruction, and then my 4 sets of cylinders, and I added depth to them so that I can actually get it. Now, as far as what that depth is, let's see what we got here. Looks like we got a, oh wait, that's not the right one, what I want. Looks like we got an 8 millimeter extension, so we got some depth there, and our overall original extrusion was about 12. So about 20 inches of depth from this surface to this surface, which will allow my generative to have plenty of material to connect these two with. Alright, and then I would go through my generative features, and you can see that I've gone through, I've still got my obstructions. This is in the same orientation that it was. Still have my obstructions, and I have added more obstructions just to make sure that I have plenty of hole clearances so I can get the screws in. Now, one of the things that you'll probably notice in this edit model that I do is that, look at my timeline down here, I did one and then I used patterns to replicate. So that way I could actually just create one block or obstruction and then pattern it all the way around. Now, one of the things that I was doing through this process, I was doing quite a bit of trial runs with my quick simulator, or not really the simulator, but just quick visualizer, so that I could see how the generative system was going to interpret this situation and see if I need to add in any other features. Now, as you can see right off the bat, it's starting to form around the things that I want it to. It's actually avoiding the big block in the middle, and it's merged this way. So you can see it kind of going up between the 4 and then into this one, and you can see it kind of getting thicker as it goes back toward the end, which is what I want because I know this is where the stress is going to be. Now, as far as the loads go, I actually did a pretty hefty load on these things. If I remember correctly, somewhere in the 20s. Let's take a look at my loads here. So edit. Yep. So I applied a force in the X direction, Y direction, and the Z direction to give this sort of like an out and down. So it's a, essentially equivalent of a 30-pound force in a certain vector. at each point. So there's a lot of force going this, and I even built it into a safety factor. Now, as far as my materials, I set it to be an ABS plastic. I made sure to set my design criteria so that it was only extruding one direction and it was only additive. And then I did a safety factor of 2 and told it to minimize mass. So this overall creation turned out pretty handy. I don't think I can show you I don't know if I can show you the previous results or not. No, I'd have to rerun it to generate it. So won't do that, but what I will do as part of this this lesson, I will export this Fusion file and add it to the lesson so that you can take a look at it. I'll also add in the STL file itself. That way you can take a look and kind of see what you think about it. Overall, it was a pretty good project, and one of the things I was really going for was how could I minimize the number of sketches that I did to create the majority of a pattern. Because if I ended up making some changes, if I realized that I didn't have enough thickness here, I wanted to be able to come back and quickly change it and improve the process very effectively. As the generative result, and to be honest, I actually questioned it. When it gave me this result as one of my options, I was like, and I actually took the extreme version of it too. So it's what it considers the best. And I was really questioning whether or not this thing would actually be able to mount to my monitor and also mount to the VESA arm or the desk arm and actually be able to handle this monitor up in the air. This is a pretty good sized monitor too, by the way, and actually handle it. But I'll be honest with you, if you actually feel this thing, it is super stout. We didn't actually do anything special. We actually have probably maybe, I don't know, only a few shells and mostly infill. And you can feel the just stiffness and strength of this object. So this actually has worked out better than anything we've created for this purpose thus far. And as you can see, it's a very interesting design. So anyway, you can check out the lesson, check out the files we provided, and you can utilize this as a good demonstration of the generative work and also just a real game changer mentality. Because, you know, if we were being asked to design this and this is your monitor arm, you know, this is essentially what we have that we're using it for. If this is your monitor arm, you know, you would think that you might need to really engage those bottom two bolt holes. You know, they would be important to do that. And truth be told, let's see if it's got one here. Yeah, get a big version. And it's got that pattern. I wanted to see one with the, yeah, looks like it's going to be that one. I want you to really see the X in it. No, anyway, if you can actually see the extra holes too. But you would think that you'd need to connect to these down here. Turns out though, it doesn't actually, you know, do that much. So these thin little legs that it whittled down turn out don't participate nearly as much as we would have thought. And the overall result that you see there is actually super stout. So I'm very pleased. Anyway, just went through that as a way to think it through. The files are provided for you in the lesson, and you can take a look at it and even print them off if you wanted to kind of get a feel for it. It's a very interesting design, it's a very strong feature, and it's worth checking out. Alright, in that case, I appreciate you all, as always, for hanging with us and learning some stuff along the way with us. Hope you have a good one, and we'll see you next time.